Hello again, our most valued student. My name is Confident. Welcome to our revision session, another of a kind, and we are now looking at a paper that was written in November 2019, and this is for students who are preparing for their mathematics N2 exams. So I just thought of bringing this. I know it is already past, and now we are in 2021, but such questions, previous papers, they help you to prepare for your final exams. So I'm just looking at this paper and I just want to show you how you would have approached it, give you some suggested solutions, and you can use the strategies and the ideas that I'm bringing here so that you can ace your exam with good marks. Now, as I said, this is for November 2019, and there are many of these revision sessions that I conduct. Now, if you have not subscribed to the channel, subscribe so that you can get notification every time there are new videos that we are adding. And also remember to turn on that notification bell so that you can be notified whenever there are new videos that we're uploading. And remember, guys, share this channel to your friends so that they can also benefit. Sharing is caring. Now, let us look at this question. As I said, it is a question paper which was written in it is a paper that was written in November 2019 on the 15th, and it was written in the morning. So let us look at a few things before we commence. Remember, guys, it's important to know your instructions. It's a 3-hour paper out of 100 marks, and you need to answer all the questions. Simple instructions are very important also to always familiarize yourself. Read all the questions carefully, number the questions according to the numbering system, start each question on a new page, and then show all the intermediate steps and simplify where possible. Use only blue and black ink, and then write neatly and legible. Sometimes they include also to say you need to round off your answers to 3 decimal places, but they didn't include in this case. Now let us look at this question. Let's start with question number 1. We are supposed to solve. So it says question 1, simplify the following without a calculator. And what I'm given here is 3 marks. It's very also important to know your mark allocation so that you can have an idea how this is working out to be. So this is what I'm given, and we are supposed to simplify that, and I'm going to ask to work from it from this point. You have got AB to the power -2 over AB, and everything is to the power -1 over 3. So these are exponents, and how do you go about solving this? Now, what you need to know, if I'm given AB, in this case, it is A to the power 1, B to the power 1, and then I've got -2 over AB. So this is to the power -1 over 3. So you must understand this 2 will open this negative like that, so that we have A to the power -2, B to the power -2. Now I have got over A, B. Also they have got power 1, and this is to the power -1 over 3, which is further equal to, now I need to take A to the top and B to the top. It will become negative. So I've got A to the power -2, B to the power -2 dot or times A to the power -1. It changes from positive to negative, B to the power -1. So that's what it does. And remember, this is to the power -1 over 3. This is equal to, now same exponents, remember you add them. So you've got A to the power -2 times A to the power -1, B times B to the power -2 times B to the power -1. This is -1 over 3. Now when exponents are the same basis, you add. So it's A to the power -2 plus -1, B to the power -2 plus minus 1, and still this is being multiplied by negative 1 over 3. I'm just taking it a little bit longer, but it's for your understanding. This is a to the power now minus 2 plus minus 1, it's minus 3, b to the power minus 3, and then you have got to the power negative 1 over 3. Similarly, this negative sign will multiply each power, so it will be a to the power negative 3 times negative 1 over 3, and then you've got b to the power negative 3 times negative 1 over 3, and when you multiply that, negative 3 times negative 1 over 3, it will give us a 1. Similarly here we'll get a 1, so the answer is a, b. So that is what we are getting here. Now you can quickly prove such questions. So what you do is you choose any value of a to say, for example, let my a be equal to 2 and my b be equal to 3. So wherever there is a, we're going to put a value of 2. Wherever there is a b, we're going to put a value of 3. So we do that in the original. So we start with the bracket, the bigger bracket, the square bracket, fraction, and then there is a smaller bracket, which is a, which is 2 times b, remember, is 3. This is to the power negative 2, and then over, I've got ab, which is 2 times 3, and then I close the bracket, to the power, and then negative fraction 1 over 3. You just choose any value of a and b that you want. You see that I'm getting a 6. So when I do that, I'm getting a 6. Let me go to my final answer also and see if it will give me a 6. Remember, a, we say it is 2 and b is 3. Now if you say 2 times 3, I'm getting a 6. So whenever the answer in the beginning matches the answer which is the final answer, when the two are matching, it means your simplification is correct. So that is how you can solve that question. So you get your 3 marks. Let us move on to question 1.1.2. Now it says it's logarithms. We are given 5. Again, the question was simplify the following without using a calculator. That was wrong for me not to read this instruction. We are not supposed to use a calculator, so we never use the calculator here. Even here, we are not supposed to use a calculator. But guess what? The moment they say don't use a calculator, that's when I take the calculator and find out what is the answer, and I work towards that answer. So I'm given 5 log in base 2 of 4 plus log in base 4 of 2. And then the answer that I'm getting is 21 over 2, which is 10,5. So I have to prove that this is 21 over 2, which is equal to 10,5. That's what I want to prove here. So how do I work about this? So what I have got 5 log in base 2 of 4 plus log in base 4 of 2. So let me check my formulas and see if ever there is anything to do with logs. And in this case, I don't have graphs, trig. Alright, so this formula sheet doesn't have anything to do with logs. So N2 doesn't have formulas for logs. So what do? You need to recall your laws or rules of logarithms. And the first things first, you have got different bases. You can see you have got base 2, you have got base 4. So you need to change either to base 2 or to base 4. Let's change base 2 to base 4 out of interest sake. So we are going to change this one. So how do I change? There is a law which says if you are given log in base A of B and you want to change it to base for example to base C, you are going to say log in base C over log in base C. See that? So the B goes to the top and the A goes to the bottom. That's how you convert bases. That's the first part. So let us look at that and see how it will convert to base 4. So we want to match the bases. So I'm going to convert base 2 into base 4. So I will have, in this case, 5 log, so base 4 over log base 4. So on top I will have the 4, and then at the bottom I will have the 2. I think that, and then plus log in base 4 of 2. So look, everything now has changed from base 2. Everything is now base 4. Also, the next rule of log here, it says log base a of a is equal to 1. So if the base and the number are matching, you get a 1. So that's what we're having here. Look at this, 4 and 4, log base 4 of 4, that will give us a 1. So what I'm going to be having now, it will be 5 times 1 over, and then I've got log base 4 of 2 and plus log, in this case, in base 4 of 2. So that's what I'm having here. And if I continue to simplify, this is over 1, so the common denominator is log in base 4 of 2, and then log in base 4 of 2 into log in base 4 of 2 is 1. 1 times 5 is 5, plus 1 into log base 4 of 2 is log base 4 of 2. Log base 4 of 2 times log base 4 of 2. So this is what it is giving me at this stage, and this will continue to become log, this is 5 plus log in base 4 of 2. As you can see, now it's twice, and then this is squared over log in base 4 of 2. So now actually something is also coming in my mind to say, in here I have that, but I could have actually done the opposite. So let me just change this. Instead of changing, to make it easier, you'll see the reason behind. Instead of changing log base 2, everything into log base 4, let me change everything into log base 2, the smaller base. So I'm going to change, it's easier if everything is taken from the smaller base perspective. You'll see the reason. So I'm going to change log base 4 of 2 into log 2 over log 2. That simplifies things actually. So the 2 is on top and the 4 is at the bottom. You can see that. So that is what this will change into. So now, which means I will have now 5. Now log base 2 of 4 will then become this part. So I will have 5 log base 2 of 2 over log base 2 of 4 plus, actually I'm not doing that right. I've got 5 log base 2 of 4 plus, that's the one I changed, log base 4 of 2, which becomes log base 2 of 2 over log base 2 of 4. So guys, this is what I'm having, and it's easier now to simplify here to say 5 log base 2. Now remember 4 is same as 2 squared. Now 2 squared is 4 plus log base 2 of 2 over log base 2, again 4 is 2 squared. So it is much easier to change to a smaller base for that case, and you'll see what I mean here. Remember, we agreed that log a of a is 1. Then there is another law here which says if I'm given log in base a of b to the power of m is equal to, you drop the m so that it's m log in base a of b. So you drop that m, and if I'm to look at this, that's what I'm going to use here. You see that exponent 2, I have to drop it, and this exponent 2, I have to drop it. So what I'll be having here, when it drops here, it will become 5 times 2 log in base 2 of 2 plus log in base 2 of 2 over, you drop that other one is 2 log in base 2 of 2. I think you can see how simplified this is now becoming, unlike when we changed everything into log base 4. The answer was still going to come out right, but it was going to require some extra laws that were unnecessary. So now log 2 of 2 is 1. So here, this is a 1, this is a 1, and this is a 1. So what I have is 5 times 2 is 10, 1 plus, and then I've got 1 over 2 and 1. So this is 10 plus half, which is 10 plus 0,5. Remember, half is 0,5, which is 10,5. And if you remember, our answer that we got in here was also 10,5. Remember, from the calculator. And while I'm working from this, I'm looking at this face, this alien kind of a face, you know, saying be careful, this paper might actually be very tricky for you, you know. But well, this is kind of a watermark that they put by the department so as to control their papers. Alright guys, so as I'm saying, this is what you use to solve this particular question, and I hope it is making sense to you. Now let us look at the next question. The next question now is 1.2, and you are supposed to solve for x in the following. These are equations. Again, it's logs, and when you're solving, you have got 3 log in base 5 of x is equal to 12 plus log in base b of 1. So now what you need to know with the calculator quickly, if you're given log, for example, log 1, log in base 12 of 1, it's 0. It doesn't matter whatever base I put. Even if I put a 1, it's 0. Actually, 1 doesn't want there. Let me put a 2, it's 0. Let me put a 9, it's 0. So any log base 1 is 0. So log base b of 1, this will become a 0. So what I have is 3 log base 5 of x is equal to 12, right? Then when I've done that, I must divide everything by 3 first to get rid of that. So I've got log base 5 of x. Now 3 divided by 12 is 4. Then at this stage, how do I find my x? You're going to say x is equal to, you take that 5 and this becomes an exponent. So x is equal to 5 to the exponent 4. It's a big number, but that is the value of x. Definitely you need to check it or you need to test it. So what you do is you take a calculator and say to yourself, in this one, 3, this is log. Now before we test the calculator, we need to be careful here because you must know how the calculator works. 3 log base 5 of x is the same as 3, is the same as log base 5 of x to the power of 3. So if I'm testing now my value of x there, it will be log base 5. Now my x, remember, is 5 to the power 4, which is 5 to the exponent 4 to the exponent 3. Let's say that actually it gives me a 64, which is different. So let me see if I put it before the log and put 3 there. There is the 12. So one of them usually is, it gives a different answer. So which means if I put a 3 as is, 3 log 5 to the power 4, it gives me a 12. Remember, this is already a 0 in this case. So guys, that is how you solve it. So in this case, x is equal to 5 to the exponent of 4. Let us move on to the other question. I'm looking at 1.2.2 here, which you are given as 2x to the power negative 4 over 3 is equal to 32. So how do you solve that? First things first, divide by 2 on each side. So you've got x to the power negative 4 over 3 is equal to 2 into 32 gives you a 16, but you need to change that 16 minus 4 over 3. You must know that 16 is 2 to the power. You can test that. So if I say 2 to the exponent 4, it gives me a 16. So that's what you need to do. Now remember, you're solving for x, so how do you get rid of minus 4 to the power of 3? If I write it properly like this, to say I'm given here x to the power negative 4 over 3, I must multiply by the inverse of that fraction. The inverse will be negative 3 over 4. Don't forget to multiply with the negative. Why? Because you want to neutralize it, and then at the same time the 3 will cancel the 3 and the 4 will cancel the 4. But what you do on the left, you do on the right, so it's times negative 3 over 4. Then you've got your x now alone, which is equal to, now you can use a calculator to say 4 times negative 3 over 4. 4 times negative 3 over 4. It gives us minus 3. So x is equal to negative 3. You can test it again. So where there is x here, we put minus 3. It must give us a 32. So if I come here and say 2 times, we need to put it in bracket, negative 3 to the power of negative 4 over 3. It's giving me something different. Let me just check if I'm doing the right thing here. It's 2 times if I remove that and remove that. Okay, let me test again. It means something is wrong then with my simplification. So let me come back and redo this again, because it was supposed to give me the answer. So let's do it again and see where I did it wrong. So we said 2x to the power negative 4 over 3 is equal to 32. And don't forget, first things first, 2 is multiplying, you divide by 2, you divide by 2, and when you do that, you've got x to the power negative 4 over 3 is equal to 2 into 32 is 16, and we said 16 was 2 to the power 4, and then I said you multiply by negative 3 over 4 times negative 3 over 4. When you do that, the 3 cancels the 3, the 4 cancels the 4, the negative, so you've got your x is equal to over 1, the 4 cancels that 4. So I see now where I made an error. It's 2 to the power negative 3. So I don't know how I calculated with the calculator, but it was supposed to be 4 times negative 3 over 4. I think the calculator gave me the answer as an exponent, not as the value of x. Now I see where the error is. I said x was minus 3, but x is equal to 2 to the power minus 3. So if I say what is 2 to the power negative 3, so 2 to the power negative 3 is 1 over 8. So this is x is equal to 1 over 8. So you see the importance of testing your answers. You don't do unnecessary errors in that case. So now let us test now with our x as 1 over 8 here. So it is very important, guys, to always test your answers. So it's 2 times bracket 1 over 8. In this case, it is to the exponent in its negative 4 over 3. So this must give me 32. So you see now that it is fine. It is giving me a 32. So that's how you solve it. Let us move on without wasting much time to 1.3. I want to cover as much questions in this section. I'm going to do two parts. Again, guys, there is the first part and then I'm going to do the second part. So I'm going to do the first 3 questions and also do then the remainder of the questions. Now let us look at 1.3. Says solve for x using the laws of logarithms, and this is what you're given. I'm just gonna have to get a little bit of space here. So you are given x is equal to that. So now the first things first, introduce logs. They say using laws of logarithms. So I'm going to say log here, you put a log there. So that's what I'm just doing. I'm just introducing logs. So log x is equal to log, then you say 3,89 times 1,89 squared over cube root of 153,8. Now they said I must use laws of logs, but I can actually find this quickly with the calculator here and find out what's the answer and work towards that. So I'm given 3,89 times 1,89 squared and all over, then it's shift cube root of 153,8, and let's see what this gives me. It gives me 2,5935, which is 2,594. So it's 2,594. So I have to work towards this answer. Always find ways. You can see that from question 1 I've been finding ways of testing my answer or using the calculator to my benefit. So that's what you also do. So what you do, let's apply now the laws of logarithms, then which is log x is equal to, which is log 3,89. Now when there's times, you add the logs, which is log. In this case, I'm just going to jump ahead and say, remember, when it's an exponent, we drop the 2, so it's 2 log 1,89 all over, because it was going to be 1,89 to the power of 2, so this 2 is the one that I dropped there. So that's what I'm saying. Okay, and then all over. Now you need to understand what is this cube root of 153,8. Now cube root is same as 153,8 to the power 1 over 3. That's what the cube root means. Now again with the logs, if I introduce the logs, it will be 1 over 3 log 153,8. Where did I get it? Remember, I was supposed to write it actually as 153,8 to the power 1 over 3. So I took this power just like that 2 and I dropped it there. So I'm just doing it to avoid unnecessary repetition of this because of my space. So that is what now I'm having. Don't forget, always maintain your log x on the left hand side is equal to, now you use your calculator to find each one now. So what is log 3,8? Use the normal log without the base. The assumption is base 10. So 3,89 is 0, let's go for 4 decimal places, 0,5899. So I've got 0,5899. It's better to start with 4, then final answer to 3 decimal places. And then after that one, we're going to find 2 log, actually 2 times, then you find log 189, 1,89 to 4 decimal places, 0,27646, which is 0,27. You can round off with the calculator. You say shift setup, say 6, and then you say 4 decimal place, which is 0,2765. 0,2765 over 1 over 3 is multiplying that log. We are finding log 153,8, and then it will give us the answer, which is 2,153,8. 2,1869, which is 2,187. As I said, you say shift 6 4, then it is 2,1870. So it's 2,1870. So you see, then you maintain your log x is equal to, now you need to use then the calculator to find, you can actually solve the top part so that you don't do too much of the calculator here, to say 0,5899 plus 2 times 0,2765, just to add the top part for now. It gives you 1,1429, 1,1429 over, then we find a third of that, which is 1/3 times 2,1870, then it gives me 0,729. You see, you continue and say log x is equal to, then you find, divide that, which is 1,1429 over 0,729. You divide that, it will give me 1 comma into 4 decimal places again, 1,56776. The 6 change the 7 to 8, which is 1,5678. 1,5678. So now you have come to the end, the final part here. As I said, what is hidden there is a base 10. So you are going to therefore say x is equal to, then you take that 10 to say 10 to the exponent 1,5678. Then you find your value of x, and the value of x, when you're changing from logs to exponent, don't forget that. So it will be 10 to the exponent 1,5678, and then it gives you 36,9 is 36,9657 to how many decimal places? Let's look to 6 to 3 decimal places is 36,966. So we've got 36,966. Now something is not right here. Something is not right, but I see where the error is, and the error came in my application of logs, because here what I was supposed to do when it was in this stage, I was supposed to use the laws properly, because what I did, yes, there is an error in my application of logs here. I see my error there, but now correct that, guys. It is an error that I made from this stage here. That's why it's always good to work towards the answer. From this stage I put a log, and I have to apply the laws carefully. I was supposed to say here log x is equal to log 3,89 plus 2 log 1,89. Remember, times means plus, but divided means minus. You see, I was supposed to say minus, so it's minus because of my space. Let me put the negative this side. Suppose say minus 1/3 log 153,8. That is how this was supposed to be. Okay, unfortunately I erased everything here, so I need to enter the values again. But if I didn't erase, I was going to use the same values anyway. So I've got log x is equal to, I enter those values again that I did, which is log 3,89. Don't forget that I was supposed to subtract instead. 0,5899 5899 plus 2 times log 1,89. What did we get? We got 0.27, I think to say 4 decimal place, 0.2765. 0.2765 minus 1 over 3 times, then we say log 153.8 is giving me shift and then again set up, round off to 4 decimal places, 2,1870, 2,1870. You see that? Then after that I've got log x. Now I'm going to do it once. I multiply and add and subtract what I need to do. So it's 0,5899 plus 2 times 0,2765 minus 1 over 3 times 2,1870, and then it gives me one answer there, which is 0,4139. 0,4139. Now remember I said there is a 10 there, so we're going to say x is 10. This becomes exponent 0,4139. Then you check if it gives us now the answer that is similar to that one. So it's 10 to the power of 0,4139, which is 2, let's just check that, is 2,5935, round off to 3 decimal places. Okay, shift setup, I'm rounding off, which is 6, and then 3 decimal places, 2,594. You can see the answers I'm matching now, which is equal to 2,594. So you see, working towards an answer will help you to always go back, check, correct, and you are able to see in real time when you're making some errors. Okay, that was 16 marks, guys. Question 2 says, given the following algebraic expressions, you are given the first one, the second one, and the third one. It says factorize each expression completely. So I'm going to factorize them here. Now what is 5a squared minus 5? Now take out 5 first because it is common. You have got a squared minus 1, and now a squared minus 1 is same as 1 squared, which is equal to 5. This is a difference of 2 squares, a minus 1 and a plus 1. All right, and then what about 20a squared minus 40a plus 20? This in a way you have to solve. Now take out, you can see 20 is common, so you take out 20 first. 20 into 20a squared, you have got a squared minus 2a plus 1, and then which is equal to 20. Now you have 2 brackets here that you're going to have, which is in this case a minus 1 and a minus 1. So that is how you factorize that. But now I'm just doing this so quick because there are lessons that I have on the full curriculum for mathematics N2, and I will encourage you to grab hold of that of those videos that shows you how I do what I do, and it will be very easier for you to follow up whenever I grab hold of those. We just sell them for a couple of, just a fraction of a price, but it will be worth having them because it helps you to understand your foundations well, so that when you come to the stage you don't struggle with that. So here, as I say, if I multiply a times a is a squared, a times minus 1 is minus 1a, minus 1 times a minus 1a, which is now minus 2a, negative 1 times negative 1 is positive 1. So this is correct. Then the other one is 10a squared minus 10a minus 10ac plus 10c. This is factorization by grouping. Look at the first 2. What's common is 10a, which is a minus 1. Again, look at the second 2, which is negative 10c Now negative 10c into that is a. Negative 10c into plus 10c is negative 1. So the brackets are the same there. I've got a minus 1, and then outside the brackets I have 10a. Actually, first things first, let me take out 10. That was fine to take out 10 as common, 10, 10, 10, 10. But anyway, I'll have here 10a minus 10c. I can still take out 10 from the first one. It will be 10a minus 1. Now 10 into 10a is a. 10 into 10c is minus c. You see, I still could have taken out like that. But if you wanted to take it out from here, just out of interest sake, you're supposed to say 10 out. You have got a squared minus a minus ac plus c. Then you group that, it was still going to give you that answer. So that is what you do to get the 7 marks. Question 2, when they say factorize each expression completely. 2.1.2 says determine the highest common factor for all the 3 expressions. Now when you want to find the highest common factor is the one that appears in all the 3 expressions 1, 2 and 3. So you check which one appears in all the 3. Now I've got, start with the number. I have a 5, I have a 20, I have a 10. So we're looking at a number that can go into 5, into 20 and into 10. That number, in this case for the HCF, the number that can go into 5, 20 and 10, the number is 5. You look at the smallest number. 5 can go into 5, 5 can go into 10, and 5 can go into 20. So the first there is 10. After that, look at the expressions that are repeating. The first one, I've got a minus 1. I also have, so a minus 1 is a tick, a minus 1 is a tick. In this one, for 10a, it's a minus 1 is a tick. So you can see that a minus 1 appears in 1, in 2 and in 3. What about a plus 1? A plus 1 does not appear. It appears here but not there, not there. A minus 1 appears here but not in the other 2. So the only thing that appears as an expression in the 3 is a minus 1. So it will be bracket a minus 1. So this becomes my highest common factor. That's my HCF in this case. Now 2.1.3 says I need to determine here the LCM. Now the LCM, you need to write everything that appears, but start with the number 5, 20 and 10. Now what you can simply do so that you don't confuse yourself, you remind yourself you've got 5. Now 20 is same as 4 times 5, and 10 is same as 2 times 5. Now this 4 is similar to 2 squared, 2 times 2, which is 2 squared times 5. So what I'm going to do is I'm going to write each and every number here for the LCM. Just on the numbers, you see I've got 2 squared, and then I've got times 5. 10 is 2 times 5, which is represented in 2 squared and 5. So the LCM in here is 20, meaning the lowest common multiple, that is the number, the lowest common multiple of 5, 20 and 10 is 20, meaning the number in which 5, 20 and 10 can go into without leaving a remainder is 20. So on the numbers I get 20. So now I'm looking at the LCM. On the numbers I got 20. Now you write each and every expression that is represented. The first one is a minus 1, so I write there a minus 1. Then the other one is a plus 1, I write it. So now you write the highest powers in this case, and then now on the second one is 20, a minus 1, which is, if I simplify this further, it is going to be 20 a minus 1 squared. So now you see the highest power now becomes a squared. I must come now and say a minus 1 must be a squared. You take the highest powers, and then on the last one I've got a minus 1, and then I've got a minus c. So you've got a minus c. You write each and every expression that is to represent each and every expression. For example, 20, 10, 5, and 20 will go into 20. A minus 1 squared is representing a minus 1 and a minus 1 squared. A plus 1 is also represented, and a minus c is represented. That's how you find the LCM, guys. Alright, so that was that. So this question is good, and you can see 7 plus 3 plus 1, that is worth 11 marks. That's a lot of marks. So let us look at 2.2. In this case, it's fractions. Simplify each of the following algebraic fractions. And as I said, all these that I'm doing them so fast because there is a lesson that there is a curriculum that I do for mathematics N2, which shows you why I do what I do. So for the first one, 3x minus 6, 3 is common. 3 into x, it's x. 3 into 3x, and then 3 into 6 is minus 2. So that is what I've done to factorize over. Now, x squared plus x minus that. There, I'll come up with 2 brackets, which will be x and x. I use the product sum method. So it will be x plus 2 and x minus 1. Let me see if ever it will give me that. So it's x plus 2. So x times x is x squared. X times 1 is minus x. X times 2 is 2x, which will give me an x. So that is correct. Now divide it, I'll change into a times. Now this will go to the top. This will go to the bottom. So at the top now I've got x plus 2 over. Now factorizing x squared minus 3x plus 2, I do this again. And if I'm factorizing, I've got my x. I'm using a product sum method. So now I'm going to have, in this case, a negative 2 and a negative 1. So that is what I'm going to have, because negative 2 and negative 1 will give me multiplying will give me positive 2, and minus 2 minus 1 is minus 3x. So that is what I'm getting, but you need to know how to factorize that. Then I can cancel out what is common. In this case, x minus 2 will cancel that, x plus 2 will cancel that, and my answer is 3 over x minus 1, and I've got x minus 1. Now this one you can test. What you do, you choose any value of x. For example, let x be equal to 11. So where there is x, I'm going to put 11 here. So it's 3 into 11 minus 6 over, it's 11 squared plus 11 minus 2 divided by, again fraction, 11 squared minus 3 into 11 plus 2 over 11 plus 2. So you've got that. You see I'm getting 3 over 100, or 0.03. I must get the same answer in here. So it will be bracket 3 over, remember x is 11 minus 1. Then again it's 11 minus 1. I must get 3 over 100. This is the same answer, or 0.03. So it means my simplification here is definitely correct. So guys, that's what I do. 4 marks is yours. Let us look at the other part. The other part is addition of fractions. So what I have here is a plus 1 over, now a minus 4 is difference of 2 squares. This becomes a squared minus 2 squared. So which becomes 2 brackets here. It's a minus 2, a plus 2. That's what I wanted to bring that to your attention. Over 2 over a plus 3 over, Again, when you're factorizing this a squared plus a minus 6, you have your two brackets in this case. So what we've got a plus 3 and a minus 2. So that when you multiply, 3 times 2 is minus 6, 3 times minus 2 is minus 6, and then plus 3 minus 2 is plus 1. So that is that. And then look at the common denominator now. The common denominator, you look at all the expressions that are represented. I must have a minus 2. I must have a plus 2. I must have a plus 3. And then see, everything is represented, and then this is over. Now a minus 2, a plus 2 into a minus 2, a plus 2, a plus 3. So I've got a plus 3 multiplying here a plus 1. It always multiplies the top. Plus 2 multiplying a plus 3 into a minus 2, a plus 2, and a plus 3, which will be a minus 2 and a plus 2. So you write the one that is not represented, plus 3 into, now a plus 3 and a minus 2 are there, so you're left with a plus 2, which is the one that is not in the denominator. Then at that stage, you need to open the brackets. It's a bit long, but it's worth it. Now a times a is a squared, a times 1 is a, 3 times a is 3a, 3 times 1 is 3. You need to know how to expand, plus 2. Now remember, a minus 2a plus 2 is that, which is a squared minus 4. We said this is that, so it will be bracket a squared minus 4 plus, you multiply 3 times a, which is 3a, 3 times 2 is 6. Always maintain your denominator as they are, a minus 2, a plus 2, and a plus 3. Then after that, you continue to open that 2, so it is a squared. Now you will open that and you will open that, so it will be 2a squared, collect like terms, which is 2a squared, and then that's all on the a squared, then plus a plus 3a, and then plus 3a. So I'm looking at a, 3a, and that 3a, and then on the numbers I've got plus 3, which is that, plus 2, and then 2 times minus 4 is minus 8, and then after that one is that one, which is plus 6, over the same denominator, which is a minus 2, a plus 2, and a plus 3. So when you work, let's work it towards this direction. So this is equal to a plus 2a is 3a squared, and then a plus 3a plus 3a, a plus 3a is 4, 4 plus 3 is 7a, and then 2 minus 8 is minus 6 plus 6, it's 0, over a minus 2, a plus 2, and a plus 3. So that's what we have here. So we can take out in this case a, which will be 3a plus 7 over a minus 2, a plus 2, and a plus 3. Now it looks a bit long and a bit, that insecurity whether it's correct or wrong, but always test it. Choose any value of x. For example, x is 7. We're going to use 7. Just any value. Put it in the first one, put it in the last one, the answers must match. So if my a is 7, I've got 7 plus 1 over 7 squared minus 4 plus 2 over 7 plus 3, and then plus 3 over 7 squared plus 7 minus 6. Just any value. You see I'm getting 197 over 450. Let me write it down. 197 over 450. I need to get the same answer here. So I've got in here 7 into 3 times 7 plus 7 over, so I've got 7 in brackets, 7 minus 2, and then I've got 7 plus 2, I've got 7 plus 3. So there's no way I can just choose a random number and the answers match. So you see I'm getting something different here, so which means somehow there's an error that I made, and I need to check where I made an error. The fact that they don't match, it means something somewhere is wrong. So I just go quickly and see if ever there's something that I did wrong. So my common denominator is a minus 2, a plus 2, and a plus 3, which was correct. So in the first one I've got a plus 3 multiplying that, and it is that, and this was correct in the first one. In the second one, a plus 3, so it's 2 multiplying that, which is also correct, which was that, and then plus 3 multiplying that. So let's see now the expansion part, and the addition is the one maybe things went wrong. So I've got in this case a squared plus a plus 3a plus 3, which is correct, plus 2a squared minus 8, which is correct, plus now 3 times a, it's 3a, 3 times 2 is 6. So everything looks fine from this point of view. Now let us see the addition here. 1 plus 2 is 3a squared. So 1 plus 3 is 4. 4 plus 3, it's 7a plus, okay, I see now where I made an error. I said 2 minus this is not 0. This is 3 plus 2, which is 6. 6 plus 6, which is 12. 12 minus 8, which is 4. So I can just use a calculator. I think I was supposed to use a calculator there, which is 3 plus 2 minus 8 plus 6, which is 3 in this case. So I am supposed to say here plus 3. So it then changes everything from this stage here to say the answer was just that. So now if I use, remember I said let x be equal to 7. Let me put 7 now in this part where it is 3 times 7 squared plus 7 times 7 plus 3 over, I've got 7 minus 2, 7 plus 2, and 7 plus 3. So there is no way answers can just match when you are doing it wrong. So you see I'm getting 199 over 450, and this is what I got. It looks like 197, but it's 199 over 450. Let me check now the other one. It was 7 plus 1, because I'm seeing I wrote 197 over 7 squared minus 4 plus 2 over 7 plus 3, and then plus, okay, plus 3 over 7 squared plus 7 minus 6. It's 197, but this one gave me 199. Again, it means somehow I missed something, because they must be identical in that. Let me check again if I'm doing this right. on the previous one is 3 times, this is 3 times 7 squared plus 7 times 7 plus 3 over 7 minus 2, 7 plus 2 and 7 plus 3. I'm getting that. And now what about the other one? Again, let me just check if I'm doing everything right here on my addition, because seems the addition is the one where things somehow are going wrong. So I've got a minus 2, a plus 2 and a minus 3. I think let me check now. I think I see again another error. See, I've got a, my denominator is a minus 2, a plus 2 is a plus 3, which is fine. And on my denominator here, and this is correct, is a minus 2, a plus 2, a plus 3, a minus 2, a plus 2, a plus 3. And then when I'm now adding 1 plus 2 is 3, then here 1 plus 3, which is 4 plus 3, it's 7a, and 3 plus 2, see, I'm still making the same error here. Let me just do this properly. The numbers, the way I'm adding the numbers, 3 plus 2 minus 8 plus 6. I don't know why I'm adding these numbers wrong. Yes, I'm getting here a 3, because 3 plus 2 is 5. And then it is a positive 3, which is what I have there. So let me just see again if ever there is a part that I'm missing. So let us test it again. Let's use slowly. Here a 7, so a 7 plus 1 over 7 squared minus 4 plus 2 over 7 plus 3, just going a bit slower now, plus, and then 3 over 7 squared plus 7 minus 6. It gives me 197 over 450 now, which is fine. Let's look at the final answer, which is fraction 3 times 7 squared plus 7 times 7 plus 3 over, now it's 7 minus 2, it's 7 plus 2, it's 7 plus 3, it's 199 over 450. So I'm getting here 199 over 450. Now, as I said, if it's doing that, I need to then let me do everything. It forces me now to check everything afresh here, just to make sure I didn't do anything wrong, because at this stage, if I can't find what is wrong, then I need to do everything again. So I've got a minus 2, a plus 2, then I've got plus a plus 3. Here, if I multiply a plus 3, I multiply a minus 2. If I say a times a is a squared, a times minus 2 is minus 2a plus 3a minus 6, which is a squared plus a minus 6, which is the same as that. So that is correct. So my common denominators are correct. So if I write my common denominators as a minus 2, right, representing a minus 2, and then I've got a plus 2, and then I've got a plus 3. Let me do that again. That first fraction into that, I've got a plus 3 multiplying a plus 1, then again plus 2. Now a plus 3 to be a minus 2 and a plus 2, and then I've got plus 3. Now a plus 3 and a minus 2, so a plus 3 and a minus 2 is represented, but I have a plus 2 that will remain in this case. So if I multiply a times a, it's a squared. A times 1, it's plus a times 3, 3a, 3 times 1 is plus 3, and then plus, now this, as I said, it is similarly a squared minus 4. So 2 times a, it's 2a squared. 2 times minus 4 is minus 8. Then plus, then you expand the last one. 3 times a is 3a. 3 times 2, it is 6. Alright, so that is that, all over a minus 2, a plus 2, and a plus 3. So that is what I have. And if I'm to collect the like terms, let me do it again, collecting like terms, which is a squared plus 2a squared, to see if ever I'm getting something different from that, and then plus a plus 3a plus 3a. So I've got a squared covered, I've got a, 3a, and 3a. Now on the numbers, I've got that plus 3, I've got that minus 8, I've got that plus 6, all over, then I must divide nicely, all over a minus 2, a plus 2, and a plus 3. Seeing that? Now let's check now. A squared plus 3a is 3a squared. Now a plus 3 plus 3, which is 7a, and then 3 minus 8 plus 6, where I think is where the error is. I've got 3 minus 8 plus 6, which gives me actually a 1. Don't know, let's see, I got a 3 previously, but now this is a 1, and I don't know where the error was there. So now if I try to test now with my a is equal to 7 on this one, which is 3 times 7 squared plus 7 times 7 plus 1 over, I've got 7 minus 2, then 7 plus 2, and then 7 plus 3. Then it gives me now 197 over 450. So you see that is now a 7. So guys, this in a way, testing my answers is, you can see I become my marker. I cannot move on, even if I move on, but I'll be knowing that this, I know I got it wrong. So that is what I do for that. Now let us move on to the next question, and this is the last one. As I said, this is in 2 parts. So I'm looking at now question number 3, and in question number 3 we are still looking at some algebra. It says solve for the unknown variable in each of the following equations. So we've got that one, the first part, and in here we have got minus 3 multiplying 2p minus 4 is equal to minus 2 multiplying 3 minus 2p. So when you're multiplying, this opens and that opens. Now minus 3 times 2 is negative 6p, negative 3 times negative 3 is positive 12, is equal to, you also open that bracket like that, which is negative 2 times 3, negative 6, negative 2 times negative 2, positive 4p. Then collect like terms, let the p's go that side and let the number go this side. It's minus 6p minus 4p is equal to minus 6 minus 12. Remember, when numbers cross the sign, they change when they cross the equal sign, the sign changes. So 4p was positive, become negative. 12 was positive, become negative. So minus 6 minus 4 is negative 10p. Check with the calculator. Is equal to minus 6 minus this, which is negative 18. You can quickly check that. Minus 6 minus 4 is negative 10. Negative 6, negative 12 is negative 18. Now divide by negative 10 on both sides to remain with p. So I've got p negative 10. It's negative 18 over negative 10. It is 9 over 5. If you press ST is 1,8. So P is equal to 1,8. Again, you need to test it. What you do, put 1,8 on the left hand side and on the right hand side. So I've got minus 3. 2 times 1,8. Alright, 2 times 1,8 minus 4. Close that bracket. I'm getting 6 over 5 on my left hand side. Remember 6 over 5, or I'm getting 1,2. Let's do it on the right hand side. See if we get minus 2 minus 1,2. So it's negative 2 bracket 3 minus 2 times, remember it's 1,8. I got 1,2 on the other side. There is 6 over 5 again, which is 1,2. So this answer is definitely correct because I have tested it. It's 2 marks, nothing to do much about. Then says solve for x by factorization. Now what I have is 6x squared minus 5x plus 1 is equal to 0. As I say, this is the product sum method I use. I multiply the first two, which is 6x squared is my product, and then my sum is the center, which is minus 5x is my sum. So I'm looking for two numbers that I multiply them to get 6, I add them to get a negative 5. So the two numbers which are the factors of 6, it's 2, actually it's 1 and 1 times 6, and the other factor is 2 times 3. So from these two factors I need a negative 5 and I need a positive 6. So it is this negative 2 and negative 3. So it will be 6x squared negative 2x negative 3x plus 1 is equal to 0. So first two factorized by grouping. 2x is common. 2 into 6 is 3x minus 1 minus 1, which is 3x negative 1 equal to 0. So I have got 3x minus 1 and 2x minus 1 is equal to 0. Now I need to solve for x here. Therefore 3x minus 1 is equal to 0, or 2x minus 1 is equal to 0. So start with the first one. Minus 1 jumps the sign. You've got 3x is equal to 1. Divide by 3 on both sides. Then it gives you a value of x. Therefore, x is equal to 1 over 3 here. You do the same thing on the other side. So 2x is equal to 1. Divide by 2. And therefore, it gives us x is equal to 1 over 2. So the values of x here is either x is 1 over 3 or x is 1 over 2. Again, you cannot move on without testing your answer. You must test both 1 over 3 and 1 over 2. So you've got 6 into, the first one is 1 over 3. So it's 1 over 3 squared minus 5 into 1 over 3 plus 1. It must give me a 0. Okay, say minus there. It must give me a 0. There is the 0. Now, instead of 1 over 3, the other value was 1 over 2. so it must give me a 0. So you can see that both answers, therefore, if they're giving me a 0, it means these two answers are correct. So here x is equal to 1 over 3, or x is equal to 1 over 2. Alright, moving on to question 4. Question 3.2 says solve for m and n in the following simultaneous equations. You are given that and you're given that. Now if you are looking at simultaneous equations, first things first, write the equations. 5m is equal to 8n minus 23. This is my equation 1 as I'm given. The second one is 6n is equal to 71 minus 7m. This is my equation 2. Now I need to arrange these equations identically. So I'm going to take m and n on one side such that the equations now are 5m minus 8n is equal to negative 23. This is still, I'll call it my equation 3 now since I'm moving on. Now start with m minus 7, m crosses the sign, it becomes 7m plus 6n is equal to 71. This is then equation 4. Now I need to eliminate. In this case, I want to remove, I'm going to use elimination. I want to remove m. To remove m now, I must match 5 and 7 such that I multiply by 7, I multiply by 5. Why am I doing that? If I say 7 times 5, it will give me 35m. You multiply each and every item by 7. 7 times negative 8. So 7 times negative 8 is negative 56. N is equal to 7 times minus 23. So it's 7 times negative 23 is equal to negative 161. So you see, now the other one I multiply by 5. 7 times 5, you see, is 35m. That's what I wanted to match. Then 5 times 6 is 30n. And then 5 times 71 is, I think, 135. 300 is what? 71 times 5 actually is 355. Then at that stage, I need to subtract equation 3 minus equation 4. So 35 minus 35, it's 0, minus 56. So I've got minus 56n minus 30n is equal to minus 161 minus 355. Because I'm subtracting. So minus 56 minus 30. It will give me minus 86n. So if I could have that, so I've got minus 86n is equal to, again I do the same thing on the right hand side, which is minus 161 minus 355. I'm getting minus 516. Divide both sides by minus 86 over negative 86 to remain with n. So my first value of n actually is equal to negative 516 over negative 86. It is giving me 6. So n is equal to 6. And then from there, I can choose any equation from the original. 5m, remember, 5m is equal to 8n minus 23. Now I know the value of n is 6, so 5m is equal to 8 times 6 minus 23. So 5m is equal to, can use the calculator to say 8 times 6 minus 23. Must be careful there, which is 25. So divide by 5, so that m is equal to 5 into 25, which is 5. So I've got two values, therefore you can see that my m is equal to 5, my n is equal to 6. These values, I must substitute them in the original and see whether it matches. Where there is m, I put that value. Where there is n, I put that value. So let's start with the first one. Now 5m, m is 5, so 5 times 5 is 25 on my left hand side. What about on the other one? 8 times n, which is 6, minus 23, I must get 25, which is fine. Let's test the other one. 6n, which is 6 times n is 6, is 36. Now 71 minus 7 times 5, my m is 5, I must get 36, which is correct. So that's how I solve that question of simultaneous equation or simultaneous equations. Now everything that I'm doing, guys, I will encourage you to grab hold of the whole curriculum of mathematics N2 so that you can in a way understand what is happening here. This question you can get all the marks provided you follow the rules that I'm using. Do I make errors? Of course I make errors. Yes, I make a lot of silly errors. Instead of multiplying, sometimes I add. Instead of multiplying by 2, find that I make an error, but I always try to test my answers, and the moment I test it, if it's not balancing, I check where I made an error, correct that, meaning in as much as I'm making the errors, but I'm able to correct myself as the exam progresses. So I want you to get that strategy because it will help you get your final exams with a good marks. Now, given the formula 3.3 now, this is the last one. Given the formula V is that, make H the subject of the formula 3 mark. We want H, so V is that which is G times B times R over 2 times H. So the first thing to do is to get rid of that square root. You square, so V squared is equal to G times B times R over 2 times H. We're interested in making H the subject, so multiply everything by 2 times H. 2 times H. So what we have, 2 will cancel 2, H will cancel H. So I will have here 2 times H times V squared is equal to G times B times R. Then remember, I'm interested in H. Divide now by 2 times V squared on each side. 2 times V squared, such that the 2 cancels, the V squared cancels, and then we have our H being G times B times R over 2 times V squared. That's our H. Now it says calculate the value of H if G is that, this is that, and this is that. Now we are using the same thing to substitute now. I'm gonna work from it here now. That is question 3.3.2. It will be equal to, now G is 9,8 times B is 3 times R is 0,3 over 2 times V squared, which is 5 squared. So when you do that, it's a matter of substitution, and then you'll have in here 9,8 times 3 times 0,3. It's 9,8 times 3 times 0,3 times over 2 times 5 squared, and then there we go. I've got 0,1764 to 3 decimal places, which is 0,176. So this becomes the final answer into that. Get your 14 marks and you're good to go. So guys, as I said, this is how you would have done this question from question 1 to question 3. Now in the next sessions, I'm going to do the remaining questions, which is question 4, and then you have question 5. See question 5, that's what I'll be doing. And then I've got also, it continues here, which is question 5, and then there's question 6, and that's the end. So it's half of it roughly half I've done, so the half is remaining. But now the second half, unfortunately, the bad news for now is I will do it for our premium members. Remember, they subscribe for an extra fee every month so that they can get exclusive videos. So the other second part, you have to be a premium member for you to be able to access it. I will encourage you. This helps us to maintain this channel, to bring more of these videos, because remember, everything is does cost us to bring these videos to you. So these members actually contribute for you to be able to watch all these other videos that you've been watching without any expense. If you want to be our premium member and want to support us, please feel free. Look at our premium membership and you can see how you can contribute and become of help to us. If you are failing to register, just send us comment on the video and ask us how you can go about, and we will direct you. We've come to the end of our lesson. Thank you.